The symptoms there, usually the most annoying, probably the most common, is a change in selectivity. Now, as I said earlier, if peaks move apart, we tend not to complain, but that state still may be the result of contamination of the columns. Certainly, if peaks move together, we do complain. If it's a gradual change, if it's a sudden change, okay, that can give us some information about what's going on. Decrease in retention very often happens gradually during column lifetime. If it happens abruptly or faster than we like, then we have to take a look at it. Anytime you're seeing a retention time changes, of course, it pays to look at T0. Okay, and specifically if we're seeing a same percentage change, a proportional change in the retention time, T sub r, and in T0, that means it's not a chemical problem, it's a physical problem. Okay, if some peaks are changing their retention time but others are not, that's not a physical problem, that's a chemical problem. Increase in tailing, okay, or peak shape problems generally. And we can actually make kind of the same observation. If all of the peaks in the separation are showing the same kind of problem, that usually is something that involves a physical problem with the flow profile at the head of the column. Okay, if some peaks are getting worse, some peaks look ugly, other peaks look okay, or even if you have problems on all peaks but the problem is qualitatively different, that suggests that we're dealing with a chemical problem. And then, of course, last but certainly not least, an increase in pressure, usually gradual over the lifetime of the column, but it can be abrupt, and that can be evidence of contamination, very often things that have precipitated on the column bed.